Activity 5B is really the heart of the last major writing assignment. Goal is that students can see the graph of a parabola. Here's the standard one, y equals x squared. See two different equations of the parabola and begin to make connections amongst these three forms. Later on, we'll add the factored form, which is also called the root form. Root form is what I call it in the videos. I call this AHK form the standard form. Other people refer to it as the vertex form because it tells you where the vertex is. We pretty much all agree that the ABC form is the general form. And this is pretty open-ended to get students to, here I am, I've got this, how can I translate it? So they've already done the graph transformation worksheet. So I think it's worthwhile at the very beginning to reinforce the idea of we are going to graph millions and millions of parabolas, and you should memorize exactly one of them. Memorize this one. Memorize y equals x squared, goes through the origin, fairly simple. The y coordinate is just the square of the x coordinate. So 1, 1, 2, 4, 3, 9. Memorize those points, memorize this parabola, and then every other parabola is just this parabola shifted, stretched, flipped. Students have a tendency to want to go immediately to the equations and forget about the picture. It is worthwhile to come back and think about these are the standard points on the parabola. Go over 2, up 4, go over 3, up 9. That's where we expect points to be on the unstretched parabola, because some of what happens in the next few activities gets the students thinking about what they're seeing in the picture. So always good to come back to what does this visual picture look like, and it's all about this one parabola here. So how do we get back and forth between the forms? This is a recap of activity 5A. So they should recognize, oh, this is the standard parabola, this parabola. It has been shifted, HK, so the vertex is now at HK, and it has been stretched by a factor of A. Might be good for them. Maybe they go to Desmos to do this. That's fine. Maybe they draw this by hand. Worthwhile to ask the students, okay, when you look at this, do you know where the vertex is? You should be able to see that the vertex is at 3, -1. And then what are the other points on the parabola? Whether they do it by hand or Desmos, good to review this stretch factor idea that we go over 1, up 1. We go over 2, up 4. So from the vertex, we go over 1, up 1. Oh, wait, we don't. So maybe you draw this unstretched first and then stretch everything. But good to make some connection to whatever picture they have, Desmos or drawn out by hand. Some connection to the stretch factor thing going on here. Again, chance to reinforce that the y change is going to be downward, but the x change is going to be to the right. So yeah, just make sure they understand the outcome of activity 5A, that this is shifted and stretched parabola. Question 2 asks them to go the other way. There is a couple of Desmos graphs. They have slider bars, and they're going to start moving the slider bars around. Again, number 2 should just reinforce the activity 5A. H moves it left and right. K moves it up and down. A stretches it. You should be able to get the correct parabola by sliding the parabola HK to get the vertex in the right location, and then doing the A last. to get the right stretch factor, noting that if the parabola needs to point downward, you need to make the A negative. There's another graphing one where they have slider bars for A, B, and C. This gets a little bit complicated. I would suggest for the most part that who's ever doing number 4, that they play around with it for a little bit. And if the outcome of this is frustrating, it's hard to get it to work, that's a good enough lesson. Hey, don't use ABC form. If you're trying to make a connection to the graph, AHK form is much better. If we have things in AHK form, that's good, that's what we want. There is kind of a big lesson in here about how can you efficiently do this, and this is kind of a hard lesson to teach. I'm not sure I want to tackle it with this group of students, but they'll realize that the slider bar for C is just moving the parabola up and down. And so the tendency is, let me fix that and then try to figure out A and B. Whereas in problem solving, you really want to do the opposite. You know what C does, and so you can just save that for the end. If I can get the other things right, but my parabola winds up being too high or too low, I know how to fix the too high and too low. The tricky parts are getting the parabola at the correct point left, right, and getting the stretch factor right. So maybe they learn some things about, oh, I know how to find the stretch factor, so I know how to find the A. That again is a visual thing. So here we might already calculate, I've forgotten what I'm supposed to be doing. If my vertex is going at the blue dot and through the black dot, maybe they can already calculate, oh, I'm going left 1 and an unstretched parabola goes left 1 up 1. But this is going left 1 up 3. And so I know already that my A value has to be 3. That's a correctly stretched parabola. And now I need to figure out the B and the C. And like I said before, the C we can fix at the end, so it's better to start with the B and figure out what the B is doing. Okay, I need to get the B over here. Now I have the B right. Now I can fix the C by sliding it up. So the order that these slider bars goes is a lesson, but it's a pretty deep lesson. I wouldn't let the students struggle too long with this. They may get caught in this loop where, I don't know, the C could be something, but they're trying to get the parabola somewhere near, and then they try to change the A value, but the A value, in addition to stretching it, is also moving the parabola left and right. It's also moving it up and down. This is a very difficult form to work with. So if they're struggling with that, I think the big lesson is this is not the good form. The good form is the AHK form. We're better off dealing with that.